If version control makes you nervous, that is reasonable. Most of us learn to protect our work like this: copy the folder, rename it, copy it again. Look familiar? Report final av2, report final av2, really final s. That pile of files is a version control system, one built out of fear. Git does the same job, with the fear removed. Here is the reframe. Git is a camera that photographs your whole project. Every photo is permanent, and you can walk back to any of them, anytime. So the belief that one wrong command erases your code has it backwards. Almost every Git command adds a photo to the album. It does not burn the old ones. Once that fear goes, everything else is easy. Here is the whole trip. One tiny project, pricing service, a single file, discount.js. We will edit it, photograph it, publish it, split the work into parallel lines, break it on purpose, and calmly repair it. At the end, AI agents will do this in controlled loops. Drop one belief now: agents do not replace Git. They make it more important, because you will be reviewing machine changes at speed. So what is really? Think of a save point in a video game. When you save, the game does not note that the player walked 3 steps. It stores where everything stands, so you can return to that exact moment. A commit is the same, a snapshot of your whole project. People say Git stores differences between versions. It does not think that way. Think snapshots, full pictures you can stand back inside. Let us make it real. Make dear pricing service, step inside, Git init. One quiet line comes back, initialized empty repository. Notice what it points at, a hidden folder kale.git. That folder is the album. Every snapshot you ever take will live in there. Delete it, and the history goes with it. Leave it alone, and nothing you do here can be lost. Now, the confusion that trips up almost everyone: Git and GitHub are not the same thing. Git is a program on your laptop, the camera itself. GitHub is a website that holds a copy of your album, like Google Photos. You can shoot all day with no internet at all. Syncing to the cloud is a separate, optional act. 2 things, 2 jobs. Commit is local, push is the network act. On airplane mode, with no internet, Git commit works perfectly. The snapshot lands in .git on this machine. Only Git push talks to github.com, sending copies of those snapshots over the wire. And drop this myth. GitHub is not where the real code lives. Git is distributed. Every clone carries the full album. One more fear, common in big companies: private code on GitHub costs money, or is not safe there. The honest answer: private repositories on GitHub are free and unlimited. And if policy says code can never leave the building, you can self-host, Gitea, Forjo, GitLab Community Edition, all free, even for commercial use. Nothing forces your trust. You choose where the album lives. Everything else in Git gets easy once you can see the 4 places your code lives. Picture packing for a move. The working directory is your messy desk. Staging is the open box. You choose what goes in. The local repository is the sealed, labeled box in your house. The remote is the shared warehouse. 4 places. Every Git command just moves things between them. Now map the commands onto the board. Git add, desk to open box. Git commit, seal the box and write the label. Git push, ship it to the warehouse. Git pull, the truck brings new boxes home. And bury the last misconception: editing a file does not change Git. Editing only touches the desk. Nothing enters a snapshot by accident. You place every item yourself, on purpose. You know that map in a shopping mall with the red dot that says you are here? That is Git to status. It never changes anything, it only tells you where you stand. Before every move we make from now on, we will check that red dot first. So let us give it something to notice, a real file. Here is our whole project: 1 file, discount.js, 1 line, take a price, return 90% of it. We create it, then ask Git status. Look at the answer: untracked files, discount.js. Git has seen the file. It has not touched it. Nothing is saved yet. Git is pointing at the new arrival, waiting. Here is the misconception to drop. The file is inside the Git folder, so Git is tracking it. No. Untracked means Git deliberately ignores it until you opt in. Nothing enters Git by accident. And read the message again. Git literally prints your next move. Use git add to track. The tool hands you the instructions. Now staging. Think of a shopping cart. Walking through a store, you pick items off the shelves and put them in the cart. You have not paid for anything, you have only chosen what goes to the checkout together. Git add is exactly that. It does not save, it does not upload. It selects what your next snapshot will contain. Let us do it. Git add discount.js, silence, no fireworks. Then git status again, and the color flips, green, new file discount.js, under changes to be committed. Green means in the box, ready to seal. And notice the misconception dying here, add uploaded nothing. Nothing has left your computer. The file only moved from desk to box. Watch it on the board. The card for discount.js slides from the working directory into staging. The two columns to the right, local repo remote, are still empty. That is the honest picture of add, one small move, one column over. Why have this middle stop at all? Because it lets you commit part of your work and leave the rest cooking. Time to seal the box. A commit takes the photo and writes a note on the back, a message to your future self. Git commit-m add discount function. Look at the reply, main, root commit, and A1B2C3D. That short code is the photo's fingerprint. Every snapshot gets one, and you can walk back to it forever. Now the biggest misconception in all of Git, commit saves my code to GitHub. It does not. Watch the board. The sealed snapshot lands in your local repo, the third column. The fourth, remote, is still empty. Your teammates see nothing. GitHub sees nothing. A commit is 100% local. Publishing is a separate, deliberate step coming soon. Let us change something real. Marketing wants a bigger discount, so we edit 0.9 to 0.85, 15% off. Before touching add or commit, asks, what exactly did I change? Git diff answers precisely. It is track changes for code, except exact to the character. And there is the block, one minus line, one plus line. Read it slowly. Minus is the old world, price times 0.9. Plus is the new world, price times 0.85. That is the entire change, nothing hidden. This little language of minus and plus is the language of all code review, and later, it is exactly how you will read what an AI agent did to your code while you were not looking. Now a trap that catches everyone. Stage the change with git add, run git diff again, and it prints nothing, empty. Did the change vanish? No. Plain diff compares your desk to the box, and they now match. To see what is sitting in the box, ready for the next snapshot, ask git diff -- staged. There is our 0.85 again. The change is staged and verified, so we seal box number 2, git commit, increase discount to 15%. The reply reads one file changed, one insertion, one deletion, old line out, new line in. 2 snapshots now exist, and either can be revisited. This edit, status, diff, add, commit rhythm is the loop you will run for the rest of your career. So where are those photos? Gitlog -- online shows the role, newest on top. 2 lines, 2 snapshots, F45D6A increased the discount, A1B2C3D added the function. Each line is a fingerprint, plus your note to future you. 6 months from now, this list is how you will answer what changed, and when, and why. One more look at that history. It is not a junk drawer of saves, it is a chain. Each commit holds the fingerprint of its parent, so F4E5D6A points back to A1B2C3D. Snapshots strung on a thread, in order, forever. Hold that image of a chain. When we get to branches, it becomes the whole story. A shortcut you will meet, Git commit -am stages and commits in one move. Handy, but no, it's trap. The dash are only auto-stages files Git already tracks. A brand new untracked file gets silently skipped, and your commit ships without it. For new files, it is always git add first. A shortcut is safe once you know exactly what it skips. Everything so far lives on one laptop. Time to publish. Think of your photo album at home and a shared cloud album. Uploading is a choice you make. The camera never does it on its own. Git push is that upload. It copies your local commits to the remote. Only then can anyone else see them. 2 commands. First, git remote add origin with the repository's address, and a misconception worth killing: origin is not a magic keyword. It is just a nickname, the default name for that address, like saving a contact in your phone. Then git push-u origin main. Watch the real output, objects counted, written, and a new branch appears, main. On the board, the last column finally fills. Both commits now sit in the remote warehouse too. Open github.com and there they are, discount.js, the same 2 commit messages, readable in a browser. Nothing new was invented. The website simply shows a copy of the album you pushed. Now a message that scares beginners. Make 2 more commits, small improvements, but do not push. Git status now says, your branch is ahead of origin main by 2 commits. Ahead sounds like a problem. It is not. Picture 2 scoreboards. Yours reads 4 commits, the warehouse reads 2. Git is just doing the math between them. Ahead by 2 simply means 2 sealed boxes are still in your house, not yet shipped. Nothing is wrong, nothing is lost. It is unshipped work, waiting. Run git push, the truck leaves, and ask status again. Your branch is up to date with origin main. Both scoreboards match. That one sentence is Git at its most reassuring. How does a teammate get all this? One command, git clone with the address. Watch, it creates a folder, downloads every file and every snapshot, the entire chain back to A1B2C3D. A clone is not a lightweight viewer, it is a full, independent copy of the whole album, moving into the house with all the boxes delivered. Pause on what now exists, 3 complete copies of pricing service. One on your laptop, one on GitHub, one in the teammates folder, each holding the full history. If GitHub vanished tomorrow, any clone could rebuild everything. That is what distributed means. No single copy is the real one. The remote is just the copy everyone agrees to meet at. Last piece, staying current. When the warehouse holds boxes you do not, git pull brings them home. But name the misconception now. Pull does not just download. It downloads and merges, fetch the new commits, then weave them into your local branch. 2 jobs in one command. That second job, merging, is exactly why a pull can one day ask you to resolve a conflict. Remember that. A branch sounds heavy, like copying your whole project into a new folder. It is not. A branch is a movable label pointing at one commit. A sticky note on one photo in the album. Making a branch costs almost nothing, because nothing gets copied. The photos stay where they are. You simply add a second flag to the same spot. Let us make one. Git switch-c feature /tiered discount creates the branch and steps onto it in one move. Now look at the log. Both names, main and feature tiered did discount, sit on the very same commit. No copying happened. 1 photo, 2 labels. And head, in the parentheses, shows which label we are standing on. Name the misconception out loud. A branch copies all my files into a new folder. No. It is a pointer. When you switch branches, Git rearranges the files in this same folder, in place. 1 folder, 1 branch at a time. Keep that limitation in mind. Later, Worktrees will remove it. For now, that is simply how the desk works. So who is head? Head is the arrow that means you are here, standing on this branch. Let us commit real work on the feature branch, a tiered discount, a better rate for orders over 100. The commit lands on feature tiered discount, and only that label moves forward. Main stays exactly where it was. Now the moment that surprises everyone. Switch back to main and read the file. The tiered code is gone. Not deleted, gone from the desk. Switch to the feature branch again, and it is back. Sit with that slowly. The file's contents changed because you switched branches. Git rebuilds the desk to match the label you are standing on. Here is the fear: if I switch, I will lose my work. You will not. Anything committed is safe on its branch, forever reachable. One honest caveat though: uncommitted changes sitting on the desk can block a switch. Git will say so and refuse to protect you. The habit is simple: commit or stash before you change universes. Time to bring the feature home. Merging sounds dramatic, but the first kind is almost nothing. While we worked on the branch, main never moved. So Git has nothing to combine. The main label just slides forward to where we already are. Picture main waiting at a bus stop, then simply walking up the street to join you. Run it. Switch to main, then git merge feature tiered discount. The output says it plainly: fast forward. No new commit was made. Check the log, and you will find no merge commit at all. Which kills a common belief: every merge creates a merge commit. Not this one. A fast forward is just a label catching up. The second kind happens when both storylines moved. On main we add a header comment at the top of the file. On the branch we guard against negative prices. Same file, different lines. Two people wrote different chapters of one book. The editor combined both without rewriting either. That binding is a new commit with two parents, a merge commit. Run the merge and Git combines the two changes by itself, no questions asked, because they touched different lines. Look at the graph: two lines split apart, then rejoin at the merge commit. And notice what this disproves: editing the same file always causes a conflict. No. Only the same lines conflict. Different lines, Git handles alone. Now let us cause a conflict on purpose, so the first one you ever meet is one you built yourself. On main we change the base rate to 0.80 and commit. On the feature branch we change the very same line to 0.75 and commit. Two universes now hold two different answers for one line of code. Back on main, run the merge. And there it is, the message that scares everyone. Complik, merge conflict in discount.js. Read the last line carefully, because it is not an error. It is an instruction: fix conflicts and then commit the result. Git has not broken. Git has paused and it is waiting for you. Take a breath and ask Git where we are. Status explains everything. You have unmerged paths, both sides modified discount.js. And right there, in parentheses, it offers a way out: use git merge --bort. Nothing is lost. Both commits still exist, safe on their branches. The belief that a conflict means you broke Git or lost data, false. Git paused, on purpose. Open discount.js. Git wrote directly into the file, and every line means something. The first marker, less than head, everything below it is your side, main's version of the line, return price times 0.80. Head, remember, is the euro. So read that marker as: here begins what you already had. The line of equals signs is only a divider, your world above, the incoming world below. And greater than feature tiered discount closes the incoming side, the branch's version, return price times 0.75. Notice what Git did not do. It did not pick a winner. It laid both versions side by side and handed the decision to you. Here is the part nobody tells beginners: you are not forced to keep either side. We decide the fair rate is 0.78, a third value neither branch proposed. Delete the three marker lines, write the line the way it should be, save. The file is ordinary code again. You made the decision, Git only chaired the meeting. Now tell Git you have resolved it. Git add discount.js marks the file as settled, Status confirms, all conflicts fixed, still merging. Then commit. That commit is the merge commit, and the pause is over. This is the whole ritual. Read both sides. Decide, delete the markers, add, commit. Calm, every single time. One more thing, and it matters, you never have to finish a merge. If a conflict lands at a bad moment, you are tired, it is Friday evening, the change is bigger than you thought, run git merge -- abort. Everything returns to exactly how it was before the merge began. Knowing that exit exists is what lets you stay calm inside one. Last scene, the team version of the same story. Your teammate pushed to GitHub while you were working. You push, and Git says no, rejected, fetch first. Read the hint, the remote contains work that you do not have. This message terrifies beginners, but look closer. Git refused in order to protect your teammates' commits, not to punish you. Put it on the board. Your local repo holds a commit the remote does not. The remote holds one you do not. Two histories, both real. If Git accepted your push, your teammate's commit would be overwritten. So the rule is simple. Bring their work to you first. Combine the two on your own machine, then ship the combined result. So, git pull. Pull is fetch plus merge, and yes, if you both touch the same lines, you will see the same conflict markers, and you already know that ritual. Resolve, commit, then git push again. Accepted. That is the whole team flow, rejected, pull, resolve, push. It repeats forever, and no part of it is an emergency. One dangerous button before we move on, git push -- force. It makes the rejection disappear by overwriting the remote, deleting your teammates' commits. Beginners find it in forum answers, and it feels like a fix. It is not. The rejection is a safety rail, and pull then push is the real fix. Leave -- force alone. So far you have merged branches alone, on your own machine. A team adds one polite step. Think of a book. You do not staple your chapter into the binding yourself, you hand it to the editor, who reads it first and then binds it in. On GitHub, that request has a name, a pull request. It means, please review my branch, then merge it. Watch the flow with our own branch. We push feature tiered discount to GitHub, and Git itself suggests the next move. On the website, the pull request shows the exact same -n plus diff you learned to read in the terminal. A teammate leaves a comment on a line, you reply, you adjust, and only then does someone press merge. Name the misconception, a pull request is not a Git command. Git only knows branches, commits, and merges. The PR is a conversation GitHub builds on top, a diff plus humans talking, before code touches main. Remember this page. Later, when an AI agent writes code for you, this exact review screen is where you will check its work. One more team habit before the fun part. Some files must never enter the album, passwords in Doto, the giant node modules folder, build junk. Git keeps a .not photograph list called .gitignore. 2 lines, and status stops offering those files entirely. The camera now looks straight past them. The misconception here is dangerous. I committed a password, I will just delete it in the next commit. No. History is permanent, that is the whole point of Git. The old snapshot still holds your secret, and everyone who clones gets every snapshot. A committed secret is leaked, and must be rotated. So ignore secrets before the first commit, never after. Now a pain you have already felt in this video. One repo folder shows one branch at a time. Switching branches rearranges the files on your desk. The bench must be swept clear first. It is like owning a single workbench. To start a second job, you clear away the half-finished first one. Here it is live. You are mid-feature in discount.js, edits uncommitted, and an urgent hotfix lands. You try to switch, and Git stops you. Read the message calmly, your local changes would be overwritten, so commit or stash first. Git is not being difficult, it is protecting the messy desk you have not photographed yet. The tempting answer is, fine, I will stash all day. Name that misconception now. Stash is a shelf, not a workflow. Shelve, switch, fix, switch back, unshelve. Hope nothing collides. Every urgent interruption repeats the juggle. It works once. As a daily habit, it is fragile. What we actually want is a second bench. Git has that second bench built in, a Worktree. One command adds a new working folder right next to the first, checked out on a different branch, same workshop, same single toolbox. We ask for a folder named pricing hotfix on the hotfix branch, and Git prepares it in a second. Your feature desk stays exactly as you left it. Ask Git where all the benches are. 2 rows, your original folder on the feature branch, the new one on hotfix. Step into pricing hotfix, fix the bug, commit, push, done, then walk back. Nothing stashed, nothing rearranged, your half-finished edits to discount.js sat untouched the entire time. Here is the mechanism, and the misconception with it. This is not a full copy, and it does not double your disk. Look at the 2 folders, only the first has a real .git, the whole album lives there once. The second holds just working files, plus a tiny pointer back. History is stored once, every bench shares the one toolbox. You could have solved this differently. Clone the repo again into a second folder. It works, so compare honestly, column by column. Clones cost full disk per copy and a separate fetch each, and their histories drift until you push and pull between them. Worktrees store history once, fetch once, share every new commit instantly, and merge in one place. Git even blocks 2 benches from grabbing the same branch. Now read that table again with different eyes, because several workers is about to mean you plus several AI agents, all on one repo. Picture a kitchen, 1 pantry, 5 prep stations, every finished plate landing on the same pass. Each agent gets its own bench, its own branch, its own folder, over a single shared repo. Setting it up is the same command 3 times. 1 worktree for the auth agent, 1 for tests, 1 for docs, each on its own agent branch. Then list the benches, your folder plus 3 agent folders, 4 rows and still exactly 1 .git behind them all. Now the table pays off, row by row. 1 fetch updates every agent. Almost no extra disk, however many agents you add. Each agent's commits are instantly visible to you, same object store, no pushing between copies. All their branches merge in one place, one history, no drift. And no collisions, Git refuses to open the same branch on 2 benches. The misconception to resist, just give each agent a full clone. Read the left column again, n separate fetches, n times the disk, n histories quietly drifting apart. That is the expensive kitchen. One honest caveat though, Worktrees live on a single machine. When your agents run on different machines, clones and forks are the right tool. On one host, Worktrees win.